Hi everyone, we are going to look at 2.12 today. So we're looking at our rules or our laws of logarithms so that we can manipulate logarithmic functions. So since logarithmic expressions can be also written in exponential form, the same properties that apply to exponents can be applied to expressions involving logarithms. And these properties allow us to manipulate logarithmic expressions to form equivalent expressions that may be useful when solving equations or graphing functions involving logarithms. So we're first going to look at if we have multiplication on the inside of a log, and what will happen is that will actually turn into addition on the outside between the logs. And I want to point out something at the beginning here. We have an arrow going in both directions, which means it can go both ways. So depending on if we're being asked to condense or expand an expression, will determine which way we are going. So for the rule, if I have log base a of x times y, I can expand that into log base a of x, so just the first term that's being multiplied on the inside, plus log base a of y. So multiplication on the inside turns into addition on the outside. And then I also want to point out that I am using the same base A, for all of them. That needs to be consistent. So let's look at our example here. We have log base 7 of 5 times x. I can expand that into log base 7 of 5 plus log base 7 of x. And then the same way, if I was given the part on the right and was asked to condense it, I would just work backwards and get log base 7 of 5 times x. Next, we can have division on the inside of a log. If we have division on the inside, that will turn into subtraction on the outside. So I can rewrite this as log base a of x minus log base a of y. For this one, order does matter. So when I look at my fraction inside of my logarithm, I have x being divided by y, which means x has to be written first, and then I'm subtracting the logarithm with y in it from it. So order does matter. So for our example, if you want to try those first, you can pause the video and then I will have my answers. So for the first example, that would turn into log base 4 of 10 minus log base 4 of w. For the second one, it's already expanded, so I'm actually going to work backwards to condense it. Well, I have natural log of y minus natural log of 6, so I keep that same natural log. And since y was listed first, y has to go in my numerator and 6 will go in my denominator. Next, we have exponents. If I have an exponent on the inside, so my exponent is on the argument of x, my exponent can actually turn into a coefficient that's being multiplied onto the entire logarithm. So this would turn into n times log base a of x. And this would be if I'm expanding. Expanding makes it come down as a coefficient. So natural log of x to the power of 12 can be rewritten as 12 times natural log of x. If I was asked to condense, any coefficient would turn into an exponent on that argument. So my 8 would come up as an exponent and I would have log of z to the power of 8. We have our change of base formula, which we have seen in previous notes, but I think it can't hurt to include it again. So I can rewrite this as log of any base of my choosing of b divided by log of that same base I chose of a. I'm going to make a little note here that c, the base that we chose, can be any base. So log base 5 of 96, if I forgot that I have the menu where I can choose any base, I can rewrite this and choose to use a base 10. So log base 10 of 96 divided by log base 10 of 5. Then I can use that log button. And I always want to round to 3 decimal places. So I get 2.836. I'm going to make a little note here as well. All right, the last thing we're going to talk about are some common misconceptions. So these are laws or rules that don't actually exist, but I see year after year that people try to condense or expand logarithms using these. So the first one is there's no rule if we have addition or subtraction on the inside of a log. So for example, if we have log base 8 of v plus w, I cannot simplify that. I cannot expand it any further. I cannot condense it any further. And so that would just be my answer. So I want to make a little note here. So that cannot be simplified further. And I want to make a side note here. Anytime we have addition or subtraction, like on the inside of parentheses, it technically makes math harder. And what I'm referencing is, I'm going to do like a side note here. If we have x plus 3 squared, that is not the same thing as x squared plus 3 squared. Because I would have to do something like this where I FOIL it and I would end up getting x squared plus 3x plus 3x plus 9. And so the reason that they are not equal is because I am missing this middle term if I try to do it like this. And this is something that comes up all the time. And so if this little phrase helps you remember to prevent this mistake down here, then great. So I'm just going to erase this. That was just a side note I wanted to mention. So the second thing I want to add here on the bottom is if we have multiplication or division on the outside of a log. There is no rule, there is no way for us to simplify that. And an example, let's say we have log, let's keep the same base. So log base 8 of z, and I'm multiplying that entire logarithm by log base 8 of x. This is another one that cannot be simplified further. I cannot merge those, I cannot expand those. That would just be the simplified version. And so these are like the rules for our logarithms.